Hello guys, welcome back to a new video. In this video, we will be solving chapter 1, review and assess questions. Question 1, refer to table 1 of this chapter to identify at least 2 areas of physics involved in the following situations, okay? First one, you have building a louder stereo system in your car, okay? So it is related to what? It's related to vibrations and wave phenomena. Vibrations and wave phenomena. Why? Because we studied that sound is related to vibrations and wave phenomena, because sound basically is a wave. And it's the vibration of particles in the air. The second the second area in which this situation is related to is electromagnetism. Electromagnetism. Why? Because you have stereos. Electromagnetism. Now, because you have speakers, okay, you have a stereo. It has, of course, magnets. It's related to electricity, so it's related to electromagnetism too. Bungee jumping, okay, if you know this game, a person will be tied to a rope and they will be falling or jumping on a hill or a mountain. So this is related to what? Because there is the motion of the person who is jumping, so it's related to mechanics. If your teacher asks you why, you should say, because it's related to mechanics. Then the second one is related to what? You have a rope. A rope, when the person jumps, it makes repetitive motions, okay? So it's related to what? Again, vibrations and wave. C, you have judging how hot a stove burner is by looking at it. So you're dealing with what? Hotness, okay? So it's related to heat and temperature. So the first one is thermodynamics, okay? And you are looking at it, okay? So this is what? This is optics, okay? It's related to looking at something, okay? How hot an object is. So it's related to optics. Cooling off on a hot day by diving into a swimming pool. Again, you have hotness. So this is what? Thermodynamics. Then you have diving. It's what? When someone dives, the person is moving, they are jumping, so there is motion. So it's related to mechanics. You can also say, if you like, you can say vibrations and wave. Why? Because basically when you dive, the water is going to make a wave. Okay, so both are correct. Which one of the following scenarios fit the approach of the scientific method? A and D are the correct answer. Okay, why? Because they follow the scientific steps. B is not correct because scientific steps, scientific method is not about difference of opinions. Here you have because of a difference of opinions where to take the class trip, the class president holds an election. Scientific method is not about difference of opinions or choosing something, okay? It's about following some steps while you are studying a natural phenomenon. Your school basketball team has advanced to the regional playoffs. A friend from another team says the team will win because their players want to win more than your school. This is not related to scientific method. Why? Because it's not about making suggestions and predicting something, okay? You have decided to select a new car by using scientific method. How might you proceed? Okay, so I'm not going to write it down, but I'm going to explain this. So first of all, you're going to observe and ask questions. You're going to observe and ask about multiple cars, for example, Nissan, Mercedes, BMW. So you're going to observe the cars and ask, okay? Then you're going to formulate your hypothesis. okay? You are going to say, for example, that Nissan is a good car, or you might say Mercedes is a good car, and you're going to formulate your hypothesis. You're going to assume something, okay, about each car, okay? Then you are going to test your hypothesis. How can you test your hypothesis? By driving each car and taking a look at the car, okay? You might take a look at the interior parts of the car, then the exterior parts, okay? Then you're going to drive it and see how comfortable is the car. Then you are going to analyze your data, okay? You are going to compare each feature of each car, and you're going to then, the final step, deducing results. I'm sorry, not the final step, the next step, which is deducing results. You will be deducing results, and you will be saying BMW is better than any of those cars that you've observed because it's a convenient car, it's a good car, it has a higher horsepower, anything you can choose. Then you'll be publishing your results. You'll be publishing your result with your classmates or with your friends or with your family, and tell them about the car that you have chosen, okay? Then they can go and test the car and see it for themselves, okay? This is just basically supporting your data. Now, consider the phrase, the quick brown fox jumped over the lazy dog, which details of the situation with a physicist who's modeling a path for a fox ignore, okay? So a physicist would ignore the color brown, okay? It doesn't matter whether the fox was brown, was white, was black, it doesn't matter, okay? What matters is that the fox was quick, okay? So you have a fox, okay, let's say this is a fox. It is, and you have a dog here, okay? This is a dog, and this is a fox, okay? This fox is going to jump over this dog, okay? Now, does it matter whether the fox is brown or white? No. It matters that the fox is quick, it's moving fast, and it is jumping, okay? We know how is the path of the fox. Over the lazy dog. The dog is here. Doesn't matter whether the dog is lazy, it's energetic, it's full, it's hungry. No. What matters is that there is a dog here and a fox is jumping over it, okay? So a physicist would ignore the color of the fox and the laziness of the dog. Yes. List an appropriate SI unit, SI base unit with the prefix as needed for measuring the following. The time it takes to play a CD in your stereo, seconds, okay, it's going to take seconds, okay, it doesn't take hours or minutes. The mass of a sports car, it's what? It's kilogram. Careful, it says SI unit. You should always pay attention that it says SI unit, okay? You might say tons, okay? Yes, ton is a correct measurement, but it's not an SI unit. The length of a soccer field, okay? It's measured in what? In meters, okay? So you'll say meter, okay? The diameter of a large pizza, okay? You can basically use centimeters, okay? Millimeters can be correct too, but I think centimeter is a more appropriate way, appropriate SI unit. The mass of a single slice of pepperoni, okay, so you have a small pepperoni like this, measuring the mass of it, because it's really, really small, so we would use milligrams, okay? A semester at your school, so a semester is basically 3 or 4 months, okay? So what unit would you use, okay? So we have seconds, and we have mentioned that we don't say that days, years, or months are SI units. So what could you use, okay? You can say teraseconds. Teraseconds, why not? It says here, use a prefix as needed, okay? So you can use teraseconds. The distance from your home to your school, okay? You can use kilometers, okay? Your mass, kilogram. The length of your physics lab, meter. Your height, centimeter or meter. Both are correct. Question 6. If you square the speed expressed in meters per second, in what unit will the answer be expressed? So careful, it says square the speed expressed in meters per second. So you have the unit of speed, which is equal to meter per second, okay? And it says square. So square both units. It says all of it, careful, okay, not just one of them. If you square the speed expressed in meters per second, so what will be the final unit? You have meters squared per second squared. Okay, this is the final unit. If you divide a force measuring in Newton, okay, by a speed expressed in meters per second, in what unit will the answer be expressed? So you have this, you can write, or you can ignore the one. You could just say kilogram, write it like this, so it becomes much easier. Kilogram dot meter per second squared. It says what? It says this is divided by, all of this is divided by meter per second. So meter per second. Take this up, okay? Take this up, and this becomes kilogram dot meter per second squared multiply S, which is the second, will come up and meter will come down. So you have second divided by meter, okay? Now, meter cancels with meter. Let me write this in a different color. Meter cancels with meter. Second cancels with second. What remains? You have 1 second here, okay? So this will be kilogram dot second, okay? This will be the final unit. Sorry, kilogram per second. Kilogram per second. Now, the height of a horse is sometimes given in units of hands. Why was this a poor standard of length before it was redefined to exactly 20 centimeters? Okay, so in the past, people were using hands to measure the height of a horse. Okay, so why is this a poor standard of length? Very simply, because hand sizes differ from one person to another significantly. The hand sizes vary from one person to another, okay? So the length of course, of the horse changes from one person to another, okay? Someone who has small hands will get a different length with someone who is measuring with, let's say, great hands, okay? They have huge hands, okay? So hand sizes vary differently from one person to another, and that's why it's a poor standard of length. Explain the advantages in having meter defined in terms of the light travels in given time rather than as the length of a specific metal bar, okay? So you have a metal bar, okay? We call this 1 meter, okay? And we have another unit, which is how light travels, the distance light travels in a given time, okay? Why using light is a better unit? Pretty simply, because the speed of light is constant and the unit will be consistent, okay? And a metal bar, guys, is going to decay, it's going to change over time, so it's not a good standard unit. Light is constant, the speed of light is constant, okay? With the right equipment, you can always get the same result. So the answer for 9 is that because light speed is constant. The speed of light is constant. The speed of light is constant. Speed of light. Now, Einstein's equation indicates that E is equal to mc squared, where c is the speed of light and m is the mass. Given this, what is the SI unit for E? Okay, so you have E, which is equal to mc squared. Okay, by the way, this is energy, so it's what? The unit of it is joule. Okay, but how can I derive this unit? How can I derive this joule? Okay, you can do it like this. Okay, because it says here m is what? M is the mass of the object. So m is measured in what? Oh, this is pretty laggy. So m is what? M is kilogram. Why? Because it's mass. And remember, the SI unit for mass is what? Is kilogram. And it says SC is the speed of light. So the speed of light is what? Meter per second. Okay, so this one will be what? C is measured in meter per second. But careful, C here is what? Is squared. So it will be meter squared, second squared. What will be the final unit? Multiply this by this, you'll get kilogram, mass, multiply by the unit of the speed of light. You have meter squared, second squared. Now, let's move on to the next question. This is, by the way, same as joule. Okay, if your teacher asks you prove the unit of joule, you should use this equation and give him the final result. Each of the following, express each of the following as indicated. 2 deci expressed in millimeters. Okay, now how can you change decimeter to millimeter? Okay, now if you remember, we have studied that to change prefix to prefix, you should first change it to its base, then change it to the unit that is asked. Okay, so here we should first change decimeter to millimeter to meter, then we can change this one to meter, and then change it to millimeter. Okay, now you have what? You will have 2 times 10 to the power of minus 1. This is what? This is changing decimeter to meter. Okay, then change this meter to millimeter. Okay, careful, we studied that if you change a base to its prefix, to a prefix, you'll divide. So you'll say 2 times 10 to the power of minus 1 divided by, how much is milli? How many milli is 10 to the power of minus 3? 10 to the power of minus 3. Put this up, this will be 10 to the power of 3. Why? Because we said if you take a number from the denominator to the numerator, it will be changing its sign. Now this one will be 2 times 10 to the power of minus 1 times 10 to the power of 3. Okay, what will be the final unit? You have 2 times 10 to the power of minus 2 millimeters. Now, question B, it says 2. Yeah, it never changes. Yes. 2 hours and 10 minutes. Express this unit in seconds. Okay, how can you express this in seconds? So you have 2 hours. Okay, you can first change 2 hours to minutes, and then add it to 10 minutes, and then express it in seconds. But let's first do this. 2 hours, first change it to seconds. Okay, so also 2 hours times 60 minutes times 60 seconds. So this one will be, you have 600, 2 zeros, so you have 700, yeah, 702,000 seconds. Is it correct? Let me see. 2 times 60 times 60. Yeah, 7,200 seconds. This is the first one. Then change 10 minutes, 2 seconds. So you'll say 10 times 60, so you have 600 seconds. Add these together and you'll have 7,800 seconds. Or you can say like this, 2 hours, and 2 hours times 60, you have 120 minutes, okay? Then you have 10 minutes, you have 120 plus 10, this will be 130. So then you have 130 multiplied by 60, then you get 7,800 seconds. It's exactly the same, just another way to express it. Express 16 grams in micrograms, okay? So you have 16 gram, because you are changing from base to prefix, okay? You are adding a prefix, which is micro, to this number, so you will divide it. 16 divided by 10 to the power of minus 6, because micro is 6. Change this number, bring it up, and it will be 10 to the power of 6, okay? Then you will have what? You will have 16 times 10 to the power of 6 micrograms. Sorry, 6 micrograms. Just in case you want to try another method, you can do like this. So you'll say 16 times, make a fraction. This is grams, by the way. The one you are changing to, which is micro, always comes up, micrograms. And because you are adding a prefix to this gram, so the powers of 10 will be coming to the denominator. So you'll have 10 to the power of minus 6, and you have 1 here. This is what? This is gram. Gram goes with gram, okay? And take this number up to 10 to the power of 6. So you have 16 times 10 to the power of 6 micrograms. Okay, this is the final unit. Express 0.75 kilometers in centimeters. Remember, if you have prefix to prefix, first change the prefix to base, then change it to centimeters. So you have 0.75 times 10 to the power of 3 meters. Okay, if you want to do it in the other way, you can say 0.75 kilometers times, make a fraction, meter comes up, you have 10 to the power of 3. Why it comes up? Because you are removing this kilo. 1 kilometer. This one goes, you have 0.75 times 10 to the power of 3 meters. Or you can simply just add it. Then take this number and change it to 0.75 times 10 to the power of 3 meters. Change it to what now? Change it to centimeter, okay? So because you are adding centi to meter, and meter is the base, and you have a prefix here, so you'll be dividing it. You'll say 0.75 times 10 to the power of 3 divided by what? Centi is how many meters? 10 to the power of minus 2. So take this up. It will be what? Remember, it changes its sign. 10 to the power of 2. So this one will be 0.75 times 10 to the power of 3 times 10 to the power of 2. You have 0.75 times 10 to the power of 5. What's the final unit? It was centimeter. Okay. Now here it says express 0.655 milligrams in grams. Remember, we said because you are changing prefix, this is a prefix milli, and this one is alone base. So this is a milligram to grams. Okay, directly add the number, directly add the powers of 10. 0.675 milli is how many? 10 to the power of minus 3 grams. Or if you want to do it the other way, 0.675 milligrams times the one you are changing to always comes up. So this is gram, milligram comes down because you're cancelling it. Because this is prefix to base, so 10 to the power of minus 3 will come up, and then these units cancel. You have 0.675 times 10 to the power of minus 3 grams. That's it. Express express F 462 micrometers in centimeters. First, as we said, because you have prefix to prefix, this is a prefix and this is a prefix, change it to meter and then change it to centimeter. Okay, so you will say what? You'll say 4 462 directly added times 10 to the power of minus 6 meters. Or if you want to do it the other way, because I directly added this number, you can say 462 micrometers times 10 to the power of minus 6 meter. Micrometer comes down, 1 micrometer, so it goes 462 times 10 to the power of minus 6 meters. Okay, take this number, 462 times 10 to the power of minus 6 meters, change it to what? To centimeters. Okay, so you'll divide it. You'll say 462 times 10 to the power of minus 6 divided by what? Centi is how many? 10 to the power of minus 2. Take this up, it will change its sign to 10 to the power of 2. So this one will be what? 462 times 10 to the power of minus 4, subtract these two, centimeter. You have 35 kilometers, 35 kilometers per hour. Change it to what? Change it to meter per second squared. Okay, there are two ways you can do this. Okay, you can either directly multiply this number, 35 times 5 divided by 18, and you will directly get meter per second. Multiply, then you'll get 9.72 meters per second. If you want to do it the other way, which is I think simpler, okay, you can do it like this. You'll say 35 times, you have kilometer first, so 1000 meter. You know 1 kilometer is equal to 1000 meter, and you have hours, and you are changing it to second. Okay, that's why I'm changing it to meter and then change to second. Hour, how many seconds is 1 hour? It's equal to 3600 seconds. Okay, these zeros goes. Okay, then multiply this number, you'll get exactly 9.72 meter per second. Okay, now question 12. Use SI prefixes in table 1.4 of the chapter to convert these hypothetical units of measure into appropriate quantities. Careful, SI prefixes, sorry, are nothing, just expressing powers of 10. Okay, so you have 10. If you remember, which one was expressing 10 to the power of 1? Okay, so you'll say what? Deca. 1 deca-ration. Okay, you have 2000 mockingbirds. Okay, 1000 is equal to what? It's equal to kilo, so 2 kilo mocking birds. You have 10 to the power of minus 6 phones. Okay, so 10 to the power of minus 6 is what? Is micro. So you'll say 1 microphone. So micro just 10 to the power of minus 6. 10 to the power of minus 9 is nano. So you'll say 1 nano goat. 10 to the power of 18, you can express it like this, 10 to the power of 6. And 10 to the power of 12, you remember as tera. So you can say 10 to the power of 6 tera minors. Or there's another unit which is equal to 10 to the power of 18. You don't have to know, but just for information, you can say 1 exa minor, which is equal to 10 to the power of 18. Use the fact that the speed of light in a vacuum is about, so this is what? You have the speed of light. This is speed. To determine how many kilometers a pulse from a laser travels in 1 hour, you have time too. Okay, this is speed, this is time. It says how many kilometers. So it needs what? Distance. Distance is equal to what? Okay. The equation for finding the speed is equal to distance divided by time. And if you want to find, here we need the distance. We have speed, which is this, and we have time, which is this one. By the way, because our speed is given in meter per second, so we should change this hour to what? to seconds. So time will be 3,600. 1 hour is equal to 3,600 seconds. Now, to find distance, arrange this equation. You have this. You have speed, distance. So if you want to try to find distance, you will say distance is equal to speed multiplied by time. So you have 3 times 10 to the power of 8 meter per second multiplied by what? Multiplied by 3,600 seconds. You'll get 1.08 times 10 to the power of 12 meters, okay? But careful, it says what? It says express this unit in kilometers. So just simply, you can get this, change it to kilometer, 1.08 times 10 to the power of 9 kilometers. And that's it. Let's move on to the next question. If a metric ton is 1,000 10 to the power of 1 times 10 to the power of 3 kilograms. So 1 ton is equal to 10 to the power of 3. It's the same. Or you can say 1 times 10 to the power of 3. How many people can safely occupy an elevator that can hold a maximum mass of 1 metric ton? So, and you have what? People of 85 kilograms. Okay. So how many people can occupy this elevator? Basically, you can divide 10 to the power of 3 by 85. You should get 11 point something, but you should say 11 people. 11 people can safely, it says safely, can occupy this elevator. Can a set of measurements be precise but not accurate? Yes. We studied accuracy and precision. Accuracy was how close the numbers are to the true value, and the precision was how close the numbers are together. Okay, so yes, some set of numbers can be precise but not accurate. How the numbers are close among each other but not close to the real value. You have significant figures. How many significant figures are in the following measurements? We said it if you have zeros with a number and they don't fall between any non-zero digits. So here, all of these zeros alone, you'll ignore all of them and you only have one significant figure. You only have one significant figure. You have this one. You have 1, 2, you will count this 0 because it falls between two numbers, 3, 4, and you'll count this 0 because it is after the decimal. And you have how many? 5 significant figures. You will not count these zeros because it is to the left side of the decimal and they don't have any numbers in front of them, or they don't fall between any two numbers. So you'll ignore all of them. You have 1, 2, 3. You'll count this one because it's after the decimal to the right side. So it is 4 significant figures. This one, 1, 2, 3, 4. You have 4 significant figures. This one, 1, 2, 3, 4, 5, 6. You have 6 significant figures. This is until question 16. I will be doing and solving other questions, hopefully, soon. See you